Hi, my name is Fang, and in this video, I'm going to briefly introduce a Shiny app that I created for the paper that I'm collaboratively doing with my PhD supervisor, Professor Dominic Liebl. And this paper is entitled Honest Difference in Differences Using Event Study Plots, a Functional Data Approach. You can find a link to the paper by clicking here, Fang and Liebl 2025, or simply watch a video of my presenting this paper by clicking the button here on YouTube. Um, Generally speaking, this paper presents a novel functional perspective on difference in differences, or DID, and it allows for doing honest inference using very nice new event study plots under violation of model assumptions of DID, including parallel trans assumption and no treatment anticipation assumptions. For those who know a little bit about DID, these two assumptions are needed to equalize ATT parameter and the DID parameter so that empirical researchers could use event study plot of DID parameter for making inference on ATT. However, if either of these two assumptions is violated, then one cannot simply use the traditional event study plot of DID parameter to make inference on ATT parameter because DID and the ATT are not equal to each other when the model assumptions are violated. And in such cases, one should conduct honest inference by using a new event study plot that we propose in our paper under violation of model assumptions. So one can find the details about this paper by simply reading the paper or by watching the video that I put here on the left side of this panel. Okay. Mm, and this Shiny app allows the empirical researchers to conduct such an honest inference by simply using a web browser without the worry about coding. But if you want to code by yourself, you could also simply use the R package that we created for our paper. And I will later show the link to the R package in this video. Okay. So in this video, I'm going to briefly introduce the Shiny app, and so you could be familiar of how to conduct such an honest inference in this Shiny app. Okay, there are generally five tabs in this Shiny app. The first tab is the Home tab, and in the Home tab, you could see a brief introduction of this Shiny app, and also two videos here. The first video is about the paper. Like in this video, I presented the paper in a brief way, and you could get a general idea about what our honest inference approach is by watching this video. Okay, and in the right side is a video about this Shiny app, or this is just the video that I'm recording now. And once I finish recording the video, I will put the video to the right side here. Okay, and the second tab is an examples tab. In this examples tab, you could conduct honest inference for a selected example that you can find here. We have six examples here. The first four examples are real life data, and the latter two are simulated data. And so, because like our approach could work for both staggered adoptions and non-staggered adoptions, you could select between them. So here I selected the fourth example, which is a real life data example. And then, as I explained in the video of paper presentation, there are two tasks that we need to do in order to complete such honest inference. The first task is that we need to construct a so-called simultaneous confidence band for our DID parameter. And the second task is to find the bounds for honest inference. The bounds are just the red ribbon for the violation of no treatment anticipation assumption and all the red corn for the violation of parallel trans assumption. So first, we need to construct a simultaneous confidence band, and we could enter the degree of freedom if we want to construct the band based on T distribution. But if we leave it blank, Then we will construct the simultaneous confidence band based on Gaussian process. Okay, so here we choose to leave it blank, and the second step in the simultaneous confidence band section, we need to set the confidence level for our confidence band. And here the default level is 95%, which is the commonly used confidence level for doing inference. And we leave it as default. Okay, and the second task is to find the bounds for honest inference. These bounds represent, as I said before, the red ribbon or the red corn that we have in our paper, and that represents the composite non-hypothesis for the new relevance testing problem that we consider. And the first step in the section of bounds for honest inference requires us to enter the time point right after which there is an anticipation of treatment. So that means, do you have a treatment anticipation, which is a violation of no treatment anticipation assumption? So the default value here is the time point starting, after which the treatment starts. So if you don't have any treatment anticipation, then you don't need to change the value here. But if you have treatment anticipation, then you need to put a number which is smaller than this, and to indicate the event time starting right after which the treatment anticipation starts. Okay, so now we just leave it as the default, claiming there is no treatment anticipation. And then if you define a treatment anticipation here, then you need also to define a control parameter to show like how wide the red ribbon would be. If you are confident on the point estimate at the event time right after which there is a treatment anticipation, then the control parameter can be small. If you're not so sure about the point estimate, then the control parameter can be large. And because here we don't define a treatment anticipation, then we leave it blank. Okay, and the second step in this section of bounds for honest inference is for setting the violation for parallel trans assumptions. So if you don't have any parallel trans violations, you just click here as default. But if you want to define, for example, I want to define the relative bound, the relative magnitudes here, and then I click here, and here we see once you click functional relative magnitudes, there is an additional blank that you need to fit in here, that you need to fill in here. And this defines the control parameter that you have for such a relevant for such a relative magnitude bounds. And usually we leave it as one as default. But if you want to change the control parameter here, you could also control it. But as you can see here, the minimum number of the control parameter is 0 and the max is 20 by a step of 0.01. So you need to define it according to this requirement in this ShinyApp. But in the R package, you could define it as you wish. Okay. And there are also some other plot argument that you can define here. For example, you could define if you want the bounds for post-treatment periods, if you only want the bounds for post-treatment periods to be plotted, or you want the bounds for both pre-treatment and post-treatment to be plotted. And here, I want it to be plotted for both pre and post-treatment periods. So I select a no here. And then there is also an option for you to choose, like if you want the original pointwise confidence intervals to be plotted. Those pointwise confidence intervals are those who are plotted in traditional event study plot. But in our paper, we argue that this does not account for the multiple testing problem and can lead to wrong family-wise false positive rate and such that the inference becomes invalid. So, but you can plot it for for a comparison with our simultaneous confidence band. And at last, you could select the position of the lanyard for the plot. And here we want to select it. For example, I want the lanyard to be appear at the bottom of the plot. And then we click start. And then we could see a plot appears here, and this is the event study plot, the new event study plot on which we can make an honest inference on the violation of parallel trans assumptions as we defined before. And you can see that here is a simultaneous confidence band, and it is wider than the pointwise confidence intervals because it considered the multiple testing problem, and the red corn represent the bounds for honest inference, and they represent all the reference values in our composing non-hypothesis of relevance of new relevance testing problem, and we would like to see if the red corn overlap with the simultaneous confidence band. If it overlaps, for example, in this area, then the treatment effect becomes insignificant over that time span. But if it does not overlap with the simultaneous confidence band, for example, in the gray area, we consider the treatment effect is significant statistically, even under a violation of parallel trans assumptions, as we define here with such an control parameter. Okay, and you could also simply download the plot by choosing the format as well as the plot width and height here, and click plot to download it. And then you could just plug it in into your paper. Okay, this is the second tab of example. And in the third tab, you can analyze your own estimates. That means you could do honest inference for your own data. To conduct the honest inference for your own data, in this tab, you need to have already the estimate of your DID parameter and its covariance. And you could to upload the data here by clicking browse here, and to upload the corresponding estimates of coefficients, DID coefficients and their covariance here. And you need to adhere to a certain format of this file in order to make it work. And you could click here to download the example file and to see what the format should be, and then adjust the format of your own data accordingly. And then all the other steps are similar, are the same as the one in the example tab. And then you could click start to get the plot, and you could also download the plot simply by clicking here. And on the fourth tab, it helps you to generate the estimates of DID coefficients and covariance in the third tab that if you don't have one yet. So you can see that please go to quick help if you don't have the estimates of DID coefficients and covariance, and you go to quick help, and here you could quickly get the estimate of coefficients and the covariance by uploading your original data files, and you could get one. And it requires you to upload two data files. The first data file is called data file, and the second data file is called treatment file. And what are needed to be included in such two data files are explained here on the panel. And you could also download the example files by simply clicking here and to find the format of the data file that you need to have in order to make it work. Okay, and you could then download the two data files here, which include the estimates of your coefficients and the covariance, which can be directly applied in this panel. And you could download the estimates of coefficients and covariance here, and then put them in here and to conduct the honest inference for your own data. Okay. And in the last tab, we have introduction of like the related researches, related package. That's where is the data set that we use example in the example tab. And here you could find that you could find a link to the R package that I mentioned before. So if you don't want to complete if you don't want to implement the honest inference on this Shiny app, you could use our R package to implement it too in R by coding. And we provide the R package here. As you see, you could click here and take a look at how to use the R package. And we also have the frequent asked questions here on this panel, and you could take a look. Okay, this is what the Shiny app is about. And I hope that you enjoy using this Shiny app to conduct honest inference for your empirical data if you want to use DID and if you're unsure about the model assumptions, if they are satisfied or not. So you need to conduct such an honest inference. And I hope you enjoy using this Shiny app and or the R package, as I said before. And so if you have any questions, please feel free to contact me by the email here. And thank you so much.